All right, welcome to Solving Algebraically Part 2, and I've got a system here. These two equations happen to be both quadratic equations, but that doesn't matter. I'm still going to use, in essence, the same strategy to solve this system of equations. And what is involved here is I'm going to try and make an easy substitution. I think what I'm going to do is take this equation that's on the top, and what I'm going to do is just add this y to the other side. Now, let me show you why I am going to do that. So I have x squared plus 3x, and that is the same thing as y. Then I'm going to take this stuff over here, and I'm going to substitute it in for this y right here. So I'm going to swap that out. And what's going to be left is an equation that has no other variables in it. And that's the important thing. When you make the correct substitution, you want to end up with only one variable. So I've got some x squareds, and then I got this 3x, and then the whole thing equals 0. So this is now an equation that I know I can solve. I'm going to collect together the x squareds, and then I got plus 3x. Equal 0. And to solve this one, I'm going to take out a common factor of x. Now, if you wanted, you could use a quadratic formula or any other method, but I just see this as a quick solution to how to get my answer. I'm just going to go ahead and factor out that x. So one of my solutions would seem to be that x could be 0, because that 0 in here makes the whole thing equal 0. And the other one might be a little harder to spot. I would like 2x plus 3 to become 0, so I am going to just work that out on the side. 2x plus 3, I would like that to become equal to 0. So if I solve this little equation here, I'm going to bring that 3 to the right side and then divide by 2. So that's my other solution. X is negative 3 halves. So here we have our two solutions for x. And of course, when you're solving, both equations involve x's and y's. So it means I have to go back and find the corresponding y's for these things. And probably the easiest way to do that is to use this relationship over here. Because then y is simply equal to x squared plus 3x. So a really easy one here is if x is 0, well, then y is going to turn out to be 0 squared plus 3 times 0. Well, that's pretty easy to work out. Looks like the y value is also going to be 0. So the solution that I get from that, maybe we'll put our solutions over here. Got a little bit of space here. So the one solution is the point 0, 0, or at least I believe that that is a solution. You should always check to make sure that these things actually are working. Now I'm going to go and find when x is negative 3 halves, I would like to figure out what the corresponding y value is there. So let's do that. So this is when x is negative 3 halves. Okay, so if I plug in negative 3 halves into the equation there that I circled up here, that's going to give me negative 3 halves squared. Okay, and then plus 3 times negative 3 halves. Okay, so that's going to be 9/4. And then this would be minus 9 halves. Okay, and I've got to build a common denominator, so I'm going to times the top and bottom of this fraction by 2's. And that looks like it's going to be 9/4 minus 18/4, and that would give me negative 9/4. So that's my corresponding y value. So here's my other solution, and that is x was negative 3 halves, and the y value turned out to be negative 9/4. All right. So it looks very much like we've got these two points of intersection, but how can I be absolutely certain? Well, what I would have to do, and I'm just going to go ahead and clear a little space here, I would like to test these out and see if they actually do work. So let's clear a little bit of room here. Okay, so we can get rid of that, and we can get rid of this. And now I've got enough room that I can go and check these. If they actually work, then they have to make each equation true, meaning make the left side equal the right side. So let's try 0, 0 out and see what happens. So if I plug in 0, 0, here's what I'm going to get. In the top equation, I'm going to get 0 squared plus 3 times 0 minus 0, and I'm hoping that that equals 0. Well, I think that was pretty obvious that it works. 0 plus 0 minus 0 is 0. Check. Now I'm going to try it in the bottom equation. So that would be 0 squared plus 0, and I'm hoping that that equals 0, and that's pretty obvious that that works. Okay, so 0, 0 worked in both the first and the second equations. So that one's good. Now what about this guy here, this negative 3 halves and negative 9 quarters? Well, let's plug it in and see what it does. So I'm going to plug in negative 3 halves and square it. This one looks like it's a little bit more work, but you know what? It won't take you that long to blast through this. Okay, so I'm just plugging all that in and then minus the y value, and hopefully this looks like it's going to turn to 0. Well, let's see. This here would be positive 9/4, and then we have in the middle here minus 9 halves, and then the double negative over here we would have plus 9/4. Now if I make a common denominator here, then what I have is 9/4 plus 9/4, which is 18/4, and then here I have minus 18/4. Well, guess what? Doesn't take you long to realize, yes, that equals 0. So that works in the top equation. The only other thing I got to check is, does it work in the bottom equation? So in the second equation here, I'm going to plug in negative 3 halves, and that is to be squared, and then I'm going to add to it negative 9/4 and see if it does equal 0. Well, when you square this, you get positive 9/4, and then here you're adding to it negative 9/4. Well, you can see pretty easily that is going to equal 0. So both these solutions work quite well. So that's where I'm going to stop with this example, and we'll come back with maybe another example.